Okay, for this video, I'll be going through the answers for your pre-WA3 practice 3. Okay, so make sure you have this set of papers. Now, first MCQ, three objects are introduced into the same type of liquid. That means they will all have the same density. Which of the following is in decreasing order? Okay, that means from the densest to least dense. And you know that if it's least dense, it will float the most, float the highest. Okay, so out of this, C is the least dense. Okay, B is the densest. So answer will be from densest to least dense because they want decreasing order. So will be B, A, C. So answer is D. Okay, next question. A body is moving in a straight line under the action of a constant force. Okay, so if it's constant force, and let's say there is no friction, or the friction is also constant. If the force is constant, that means the acceleration will be constant. So which of the following will occur to the body? Straight away, change in acceleration will be wrong. Change in mass will also be incorrect, because why would the body change its mass? And inertia is linked to mass, right? The larger the mass, the larger the inertia. So it's linked to mass, so also there will be no change, therefore will be change in velocity. Alright, because when there's a force, then there will be acceleration, therefore there will be a change in velocity. Okay, next it is a moments question. A uniform meter rule of weight 2.0 Newton. So uniform is important because it tells you that the CG is in the center. Okay, CG in center. So it is at the 50 cm mark. Okay, because this is a meter rule, so it's in the center. So this is the 50 cm mark. So there'll be a 2 Newton here. It's pivoted at the 60 cm mark. So this is where the pivot is. Okay, and I have a 4 Newton weight suspended from one end. So it causes it to rotate about the pivot, right? Because the perpendicular distance here is 40 cm. So the moment will be 4 times 40. So it's 160 Newton cm. For this 2 Newton, it is the perpendicular distance is 10 cm. So it will be 20 Newton cm. Okay. Now at the instant when the ruler is horizontal, what is the resultant turning moment? So it will be, this is clockwise, this is going to be anti-clockwise. So the resultant moment will be 160 Newton cm. We take the larger moment, subtract by the smaller moment, we get 140 Newton cm. And we see that the answers are all in Newton meter, so I need to convert, I need to divide by 100, so answer will be B. Because in this case, they tell us that there is a resultant turning moment. Okay, unless the resultant turning moment is 0, then it will be balanced. But you can see that the clockwise moment is larger than the anti-clockwise moment. That's why you will rotate about anti-clockwise. Sorry, you will rotate about clockwise. Now, what makes an object the least stable? Okay, to be stable, the CG, to be stable, the CG has to be as low as possible. As low as possible. You did a few questions in your tutorial. You find that for the base of those cups, right, or the knockdown eggshell, that toy, they always put something that is denser at the bottom, right? So as to bring down the CG to be as low as possible. Next criteria is for the area of base to be as wide as possible, as wide or as large as possible. Okay, so this one should be easy. Low, then large. So answer will be D. Oh, but they're asking for least stable. Okay, I'm sorry. So cannot be D. The center of gravity to be high, and area will be small, so it's A. Okay, so really need to read the question. Okay, question 5. Liquid X and Y are stored separately in large open tanks. Liquid X and Y have densities of 800 kg per meter cube SI unit. 1200 kg per meter cube respectively. At what depths are the pressure equal? So we are asking for the same pressure, right? Okay, so then we need to assume some things. What is the liquid pressure? Pressure equals to rho GH, right? We need to state that the G is the same, right? The density, of course, is different. The height is also different. So comparing between these two cases, what is common between them? Px must be equals to Py, right? Px equals to Py. Then, can I say that rho x G Hx equals to rho y G Hy? Okay? So, in solving physics question, it is common to find things that are common between the two cases. In this case, now we have two cases of different density liquid, but they are asking us to find where the pressure are equal. That means I arrive at this thing called Px equals to Py. Then we change Px into the formula so that we can input all the data in. So rho x G I can cancel because they are both the same. Hx equals to rho y Hy. Now rho x is actually 800. I substitute in. Hx I don't know. I'm supposed to find. Rho y is 1200. Hy I don't know. So now I will need to guess and check. So obviously Hx must be larger than Hy. From here, Hx must be greater than Hy, right? Then they can be equal. That means A is out because Hx is smaller than Hy. Similarly, B is out as well. They cannot be equal. So it's either C or D. So now I just need to substitute. Maybe I try my luck for C. I sub in 15 meters for Hx. And what do I get? 800 times 15. I get 12,000. Okay, let's say it's Pascal. No, let me just give it as a value because I didn't multiply by in my G, right? So this is for X. For Y, if it's true, then I put in 1200 multiplied by 10 and I also get 12,000. That means C is the correct answer. Okay. Okay, then now we go to structured question. Hot air balloon has a total mass of 150 kg. Let this be M. So it's very important to annotate so you can know what are the formulas that you can fit all this data into. The balloon rises with an acceleration of 0.4 meter per second square. So this is my A. Then I will have trained you all to think that whenever there's acceleration, there's going to be F net. Okay. So they want us to calculate the magnitude of the net force acting on the balloon. Okay, they want us to calculate the magnitude of the net force. So because I have my acceleration, so F net equals to ma. So I substitute in 150 multiplied by 0.4. I will get 60 newtons. So net force is 60 newton, 1 mark. Hence determine the upward thrust acting on the balloon as it rises. So let us draw our free body diagram. So if the hot air balloon has mass, right, which is 150 kg, right? And this mass actually is the weight, right? By calculating the mass multiplied by G. So I have 1500 Newton. Always make sure that the mass is in SI unit. Okay. So downward force is 1500 Newton, right? And the net force is upwards. Why upwards? Because they say the balloon rises. Definitely is going up. And we have done our calculation for F net, which is 60 Newton. So there must definitely be an upward force. Okay. So this is our upward thrust. Okay. So how much should the upward thrust be so that the net force is 60 Newton upwards while the weight is 1500? So upward thrust. okay, minus weight because they are opposite in direction, and upward thrust must be larger than weight. That's why the F net is upwards, should be equal to 60 Newton. So upward thrust, up thrust is equals to 60 plus 1500. Therefore, it is 1560 Newtons. Okay, so when you draw your free body diagram, you are actually able to visualize, right, put down visually what are the forces acting on it. So the purpose here is to find and tally that your F net is 60 Newtons. Okay. Okay, next is a density question. A metal alloy is made from a mixture of 500 grams of iron. So this one I will put Mi, and 120 grams of cobalt, I put it as MC. Iron has a density of 7.8. Let's annotate. It will be rho I. And cobalt has a density of 8.8. This is rho C. So define density. Density, it is the defined as mass per unit volume, okay, of the substance. Now, assuming there's no chemical reaction, calculate the density of the metal alloy in kg per meter cube. State clearly how you arrive at your answer. So this thing is 3 marks because it will involve you converting your grams per cm cube into kg per meter cube. Okay, so let's see how to do it. So we are given for iron, we have the mass Mi equals to 500 grams. Okay, the density of iron is 7.8 grams per cm cube, and our formula or our definition actually comes from the our formula comes from a definition or vice versa. So density equals to mass over volume. So substitute this, we can find the volume of iron. So 7.8, right, equals to mass 500 over volume. So the volume of iron will be, okay, volume of iron will be 64.1 cm cube. Okay, we can do so, repeat for cobalt. So mass of cobalt equals to 120 grams. Density of cobalt is 8.8 grams per cm cube. So volume of cobalt will be 120 divided by 8.8. Using the formula, I'll get 13.6 cm cube. So this is actually an alloy. So I must, in order to find the density of this alloy, I must use total mass over total volume. The total mass will be 500 plus 120. Total volume will be 64.1 plus 13.6. Okay, so I'll get 620 over 77.7, so equals to 7.89 grams per cm cube. Now to convert from grams per cm cube to kg per meter cube, I multiply by 1000. So the final answer will be 7980 kg per meter cube SI unit. Okay, so this is something that you need to memorize, but do memorize it as one way. That means for me, I will not be able to do the conversion during that means I will not be able to convert grams to kg, cm cube to meter cube very smoothly in exam, right? There's the pressure involved. So I just memorize that from grams per cm cube to kg per meter cube, I multiply by 1000. It may look a little bit weird because grams to kg by right, you need to divide by 1000. Okay, but because of the cm cube at the bottom to meter cube, you are dividing by a million. Okay, so if you are not very good in math, memorize this part. Okay, then we go to question 3. It shows a block of mass 3 kg. So again, annotate, let this be M. It's being pulled by a force of 25 Newton to the right. It moves with a steady speed of 0.5. So if something moves with steady speed, that means there's no acceleration. Constant speed, no acceleration. That means there's no F net. So how can this be? I'm pulling with 25 Newton. Okay, that means there is a opposing force of 25 Newton. That means the frictional force is 25 Newton acting to the left. Okay, so again, using free body diagram, it helps a lot. I must also warn you, sometimes you put this value on top. Some students, if you didn't read carefully, you will think of it as 0.50 meter per second square. You will treat this as your acceleration. Okay, so please be careful. Okay, then next part of the question, the pulling force on the block is then increased from 25 to 40. So let me now draw the new free body diagram. 40 Newton. And assuming it's still on the same surface, I'm going to have a frictional force of 25 Newton still. Okay, so any other forces acting in a horizontal direction? There isn't any. So 40 minus 25, we get 15 Newton, and this is our new F net for part B. Okay, but they want us to calculate the acceleration. Whenever there's F net, there is going to be acceleration. So F net equals to ma, 15 equals to mass. Mass is 3 kg. No need to change because already in SI unit. So the acceleration is 5 meter per second square. Okay. Now, when the speed of the block reaches 5 meter per second, the 40 Newton is completely removed. Meaning, draw free body diagram again. Okay. Previously, there was this 40 Newton. There was a frictional force of 25 Newton, right? But then now, when the speed reaches 5 meter per second, this force is completely removed. Any other forces acting? The frictional force still exists, right? So, the F net now is in this direction. The F net is now 25 Newton. The F net is now the frictional force. Okay, because this force is removed, this force of 40 Newton is removed, doesn't mean the frictional force is removed. It is still traveling, right? It is still traveling. But which direction is it still traveling? If the 40 Newton was removed, the motion will still be traveling in the original direction, right? Because it still has speed, so it will later slow down. But the motion is still to the right. But you notice that F net is now to the left. So F net is now opposite in direction of motion, meaning it will slow down. I think I covered some questions before. If F net is the same direction as motion, it will speed up. If F net is opposite in direction of motion, it will slow down. So in this case, it will slow down. So they want us to use numerical calculation to support our answer. Okay, so now all I know is F net is equals to 25 Newton. F net equals to ma, so equals to 25. Now my mass still remains at 3. My acceleration is a. So what is my acceleration? So it will be 8.33 meter per second square. But it will not be an acceleration. It will not be a positive acceleration. It will be negative acceleration, right? Because it is slowing down, because F net is traveling. F net is in a direction that's opposite to the direction of the motion of the box. Okay, so the box will actually move with a constant deceleration of 8.33. Deceleration of positive 8.33. Okay, because deceleration cannot be negative, right? Next thing, state the principle of moments. This one you can actually find in your notes. But what is the purpose of them asking us to state the principle of motion? Because you are going to use it in part B. Okay, so for part B, so it shows a uniform wheel of mass 18 kg. So I will need to take note of this, mass 18 kg. So this is the M. And because we are dealing with moment, so moment equals to force times perpendicular distance. Okay, so later on I'll be working with force, and this mass is actually can be changed to the weight of the wheel. So W equals to mg, m is 18, the g is 10, so definitely the weight is 180 Newton, and because it's a uniform wheel, so it must be acting vertically downwards right from the CG. And it has radius of 25 cm. It's pulled by a horizontal force, F, against a step of height 8 cm. 8 cm is over here, yeah? State what is meant by a uniform wheel. That means the CG is in the geometrical center. Okay? Okay, if you look at the answers that we upload, you will see that there are also mentioning of the mass of the wheel is equally distributed. Okay, so anything that's uniformly, the mass is equally distributed. You cannot say that the weight is uniformly distributed. The weight is where the CG is. Okay, the weight is where the CG is, and CG is the point whereby all the weight, entire weight, seems to act on. Now draw an arrow W to indicate the weight of the wheel. I've done that. I got my 1 mark. Calculate the weight. I have done that. So I got 180 newtons. Now the so actually all this is to help you, right? If the question is to be more difficult, I will actually cross out all these questions and straight away ask you to calculate the value of this force, because you are supposed to apply principle of moments. Now, the perpendicular distance from the line of action of the weight of the wheel to the edge of the step is 18.3 cm. Calculate the moment due to the weight about the edge. So this edge of the step is actually the pivot. Okay. Okay, let me do the diagram side by side so that you can see what's going on. They want us to calculate the moment due to the weight about the edge. So the pivot is actually at the edge. Can you imagine I have a force that's pulling it to the right? So this wheel is supposed to turn up this way, right? And where it turns, it will always be in contact with this edge. So this edge is where the pivot is. Okay? And they are saying that the perpendicular distance, which is the most important thing in the moment chapter, from the line of action of the weight. So this is the line of action of the weight. Remember, always extend the weight. Okay, is 18.3. So this is the point. This is the pivot. So I can safely assume that this is the perpendicular distance of 18.3 cm, right? Point to the line of action of the force, and we have a perpendicular distance indicated by the perpendicular sign that I just drew. Now, moment equals to force times perpendicular distance. Okay, and take note they want in meters. So the force is actually 180. The perpendicular distance provided for me is 18.3, but I need to convert it to meters. So I calculated out my answer is 32.9 Newton meter, right? Okay, hence determine the force so that the wheel just begins to turn, That means it's just going to exit the state of equilibrium. But before that, it was actually, when the force is just nice, it will just be at that point of equilibrium, alright? So I'm going to pull this picture down again, so you can see. Okay, so this force is actually here, right? And we have identified that this is the pivot, right? So now we need to calculate what is the perpendicular distance of the line of action of the force to the pivot. So again, this is the line of action of the force, F, and this is the pivot. So isn't this the perpendicular distance, right? Point, line, perpendicular distance. I say again, point, which is the pivot, the line is here, the line is this, then this will make it the perpendicular distance. Maybe I draw it over here. Okay, so it's really very important to be able to identify the perpendicular distance. Now, what is this length? I know that from one edge of the other edge is a total of 50 cm. 50 cm, yeah? Which is the entire diameter of the wheel. But I have a 8 cm height of platform here. That means this perpendicular distance will be 50 minus 8 is 42 cm. So this finding of perpendicular distance is extremely important, okay? So determine this force. So maybe I calculate what is the moment first due to this force, equals to force times perpendicular distance. Moment equals to force times perpendicular distance times 42 cm, but actually I need to convert it to meters, right? So I'll get 0.42 F. The unit is Newton meter. Okay, and because this is the pivot, this will generate a clockwise moment, but the weight about the pivot will generate a anti-clockwise moment. And because it's just beginning to turn, so I can still apply principle of moment just before the force becomes large enough. So previous moment was 32.9. Okay, clockwise equals to anti-clockwise. Then over here is 0.42 F. So I do my math, and I will get 78.4 Newton. Okay, so this is the answer. Okay, question 5 is shows a hydraulic press which is filled with an incompressible liquid. Yes, and I check out the area is given as area, not diameter. Previous video I also told you that please be careful if the dimension of the piston is given in radius or diameter. Okay, so please take note, because anything with square, you have to be careful. So what is common between these two pistons? The pressure at P is equal to pressure at Q. Okay, so force P over area P is equals to force Q over area Q. So you see, for physics question, calculation which involve two scenarios, in this case is piston P and piston Q, I identify what is common between them. Basically, is the pressure. Then I convert their pressure into the respective formula. So I arrive at Fp over Ap equals to Fq over Aq. Okay. So now a downward force is applied on piston Q. Determine the minimum force needed to lift the 1500 Newton load. And this 1500 is at piston P. So I have 1500. Always check that you are given the force, or if you are given the mass, please do your calculation to weight. So area P is 25. So after that, I substitute in FQ unknown. I'm supposed to find area is 5. Therefore, FQ will be 300 Newton. Okay, so you have your answer for this. Now the same load is raised by 0.4 using the minimum force. Calculate distance moved by Q. So this one you can't really do yet unless you have already covered principle of conservation of energy and the idea of work done. So we shall skip this first. If you're interested, next time we can come back to this question. Now state how the minimum force required if air is introduced. I think this question came out in tutorial. This came out also in the other sets of practice paper, so we'll just skip. Okay, now figure 6.1 shows a jar with dimension shown containing a liquid of mass 3 kg. So this is M, and density is this. So this is our rho. The height is 20 cm. Take note, this is in cm. So later we may need to convert it to meters. The area is meter square. So everything in SI unit. So the liquid exerts a pressure on the base of the jar. Determine this pressure. Now this is contact pressure, so pressure equals to force over area. Okay, so basically I cannot do that because I don't know the volume. Okay, or can I do that? I can. Okay, so basically what is the total weight? The weight is 3 kg times 10. Okay, over 0.0100. Okay, but I discovered that we cannot do this because the force due to the liquid acts on an area larger than the given area of 0.1. Alright, because the side of the jar is slanted, so we actually need to use the liquid pressure formula. Okay, so if the jar is a perfect shape, cylindrical, okay, or rectangular, then we can use P equals to F over A. But because this is slanted, so we cannot use that formula. So the density is actually 600 the G is 10, the height is actually 20 over 100. Okay, so I will get 1200 Pascal. Okay, and that's the end of this. So just take note that if it is not a regular shape, it's slanted, then we cannot be using pressure equals to force over area. Okay, because of the slanted side. So we have to use our pressure equals to rho GH. Can?